Hi guys. Okay, so let's look at the last two questions, 63 and 65, the homework problems from chapter 2. And here, these are the density problems. So in 2.63, I'm going to do part A, which is a solid object has a mass of 1.65 pounds and a volume of 170 milliliters. And the question is saying that what is the density in grams per milliliter for each of the following samples? So here we see we are giving the pounds and the question is asking her to find it in grams. So we are going to convert the pounds to grams first, and then we will do the problems here. So let's do it. Okay, so this is what is given to you, 1.65 pounds, and you're given the volume, 170 milliliters, and we know that. Now, this is again, you need to look at the tables. I will not be providing you with all these equalities. You have access to the handout, and so you should know where to look for the data in the tables. So this is, you will look at the equality table where the pounds and the grams are shown, related. So you take that. Another thing that you should know and, write down what you need to find. In this case, you are finding the density. So, and you should know the formula of the density. Density is mass over volume. So mass is in grams, volume in this case is in milliliters. Okay, so let's do this now. 1 point, write down what is given and the conversion factors. So we know the conversion factors of 1 pound over 454 grams or 454 grams over 1 pound. Okay, so these are the two conversion factors of the equality. So which one we will use? We are going to convert 1.65 pounds, right? 1.65 pounds, convert that to grams, because the formula, the question is asking us in grams per milliliter. So how will we do this? We are going to write down here 1.65 pounds multiply by that conversion factor where the pounds, the pounds are in, what am I doing here? The pounds are in the denominator and the grams are in the numerator. Okay, so this converts the pounds to grams. And in this case, the pounds, not very good, LBS. Okay, sorry about that. Okay, so LBS and LBS cancel out, and you have now a new number. Okay, as you can see, 1.65 times 454 gives you 749.1 grams. Okay, now, next thing is that you are going to write the formula. The density is equal to mass over volume. And so here we see the mass, always write the formulas. Mass is 749.1 grams over the volume is 170 ml. And the rest is you do the math, which is the division. Okay, so from the calculator, I get this number 4.4064 and so forth. Now, here's something you have to keep in mind, that if the question, and especially the density question, because anytime, you have measurements, wherever there are measurements require you to use a significant figure. That's like something, which is like it's understood. So, measurements are using the measuring device and all that. All the time significant figures are used. But if you're doing just simple calculations like, just calculations and maybe in stoichiometry, there it's okay not to use the significant figures because you're already rounding up numbers in the, when you take the periodic table, like the mass numbers and so forth. So, I mean, it depends. read the question and then go from there. But in general, anytime you use a measuring device, yes, for density, significant figures, you have to do it. Now here, look at this. This is a division, right? Now this is 3 significant figures, exact number, right? 3 significant figures. Here, 1 and variable also. So 1, 2, 3, 4. 4 significant figure. So kind of just the rule of the thumb is lowest significant figure, right? So here we will use these exact numbers, 3 significant figures we will use. So we will keep this here, 1, 2, 3, okay? And we're going to drop 6, okay? And because 6 is more than 5, so 0 becomes 1. So then this becomes a little bit more exact. This is 4.41 grams per milliliter. It depends, it's like sometimes some places, like some of the book, like your book is not talking about the exact numbers the way I'm talking. So your book is giving you 4.4 grams per milliliter. I mean, that is also okay. Okay, 2 significant figures, because what they're considering is that this and this is the 17 is just 2 significant figure, whereas I'm looking at it as 3 significant figure. Okay, remember exact numbers, 3 significant figures, 2 significant figures, 4, all those are possible. Okay, so here we have 2 significant figures. No, it's fine. And this is 3 significant figures. Now you will get a sensitivity to these numbers when you start actually performing the experiments, when you actually start gathering the data, then you will realize, like it's good to have like 2 or 3 places after the decimal. So that's more exact, more sensitive. Okay. All right. So that is one question. And that is 63A, and you're going to do the rest yourself. Let's look at the next question now. Okay, so the next problem is, the last one is 2.65, and you're given these 3 parts. Okay, so you can do part 1, that is A, yourself, and B is also of a little, difficulty. You should do it, but I'm going to do C, which is a little bit more like challenging. Okay, so I'll do C, where you are using the density formula to to do all these conversions and find the unknown. Okay, so here a sculptor has prepared a mold for casting a bronze figure. The figure has a volume of 225 milliliter. So volume is given. If the bronze has a density of 7.8 grams per milliliter, so volume and volume, milliliter are matching here. Okay, so 7.8 grams per milliliter, that is the density, that is also given. How many ounces of bronze are needed in the preparation of the bronze figure? So here we need to find the weight of the bronze in ounces. Okay, so how are we going to do this? Let's set up the problem first. Give me a minute. Okay, so this is the way you set up the problem. So first of all, you find out all the things that, write down all the things that are given to you and that are known to you. So in this question, you are given 225 milliliters of bronze, and the question is asking you how many ounces of bronze is there. Okay, and then the given is the density, grams per milliliter. Now, these are known from the tables, the relationship between the grams and pounds, and then the pounds to ounces. Now, why do we need all this? Because here's the thing, the question is asking us in the ounces, and we are given the grams. And so we don't have a direct conversion of grams to ounces. Grams to ounces doesn't exist. You need to convert grams to pounds and then pounds to ounces. Okay, that's going to be the strategy. Okay, so how do we do that? And we need to eliminate the milliliters completely. So these are the conversion factors. For the density, the conversion factors are 7.8 grams over 1 milliliter, or 1 milliliter over 7.8 grams. Okay, these are the 2 conversion factors, these 2. Okay, similarly for the pounds, 1 pound over 454 grams, or 454 grams over 1 pound. Okay, other one is 1 pound over 16 ounce, or 16 ounce over 1 pound. Okay, so these are the conversion factors from the known equalities. So now we are going to set up the problem. So here's, you're going to write on first, let's do this, 225 milliliters. So 2 25 milliliters of bronze, multiply by, we need to get rid of the milliliters. So we are going to take this conversion factor, 7.8 grams over 1 milliliter. So that cancels out the milliliters. Okay. Next is convert the grams to pounds. Remember, this is our strategy, grams to pounds and then to ounce. So here, what conversion factor will you use? Something that cancels out the grams, right? The thing that you want is going to be on the top. So here you have 1 pound over 454 grams. All right. So this cancels out the grams. Next is we still need to move further because the question is asking us for the ounces. So ounces on the top, pounds at the bottom. So which of the conversion factors are you going to use? We will use this one. Okay. So these conversion factors, 16 ounce over 1 pound. So if you look at it in diagonally, milliliter cancel out, grams and grams cancel out, pounds and pound cancel out, and you're just left with the unit of ounces. So next thing, just simple multiplication, 225 multiply by 7.8 multiply by 1 multiply by 16, divided that by 1 times 454 times 1. And what answer do you get? And this is actually ounces. So let's look at the answer. Okay. As you can see, so when you multiply, you get the answer on the calculator, 61.8502200, whatever, all these big numbers. But now comes a question, how many significant figures, right? Density problems, all these, they always have significant figures. So here you see the lowest number of significant figure. So it's not like you're going to have like, just because it's 1, so all these 1, so it's going to be 1 significant. No, exact numbers, you use a little bit of the common sense, and you obviously, you can write it in 1 significant figures, but it doesn't make sense. So you will have to just, let that one go. But I'm going to just take these away. So just focus on the decimal one. So here, according to this, we need 2 significant figures in the answer. Okay. So we need to keep this. We need to keep this, but we need to drop off 8. But 8 is more than 5. So 1 becomes 2. So now your answer is 62 ounces. That's the answer. So guys, how I'm showing you, with the numbers and the units and all the steps, this is what I want to see on your tests. Okay, exactly same way. All right, guys. So this finishes the homework, and this is very bare minimum. Only one or two questions, very minimum. But you have the option of practicing few questions on your own. Okay, independent learning, very important. And you know where the answers are at the back of every chapter. Their answers are already written. So just make sure that you check your answers. Consult the solutions manual, but consult, only refer. Don't start copying, okay? It won't help you, okay, guys? All right. Thank you so much. Take care. Bye-bye.